Okay, a little harder today. Last day of solving rational equations, third day. So, how do we find the least common denominator on this one? We have to factor one of those denominators? Yeah. Which one? Yes. How does a squared minus 9 factor?
A plus 3 minus 3.
Yep. So what's in this denominator that's not in this one? A plus 3. So this one we're good. What is missing in this denominator? A minus 3. So I'm going to go ahead and multiply it out just to give myself less steps there. So we're going to use the claw, and we would get a squared plus 3a minus a and minus 3. So that's going to simplify to a squared plus 2a minus 3. And then plus 1 over a plus 3 times a minus 3 equals, now multiply this out. Let's see, this group here. Multiply it out for me. What do you get?
A squared minus 3a minus a.
So we could add our like terms there, right? And what would we get for our like terms? Negative 4a, just to save some space. So now, what's our next step? Let's save that finger. What's our next step? Get rid of the denominators first, right? So multiply both sides by the a plus 3, 8 minus 3. What is a plus 3 times a minus 3? What do we get when we multiply that? It doesn't matter. I was thinking that we would need it for one of them, but we don't. So these cancel, and these cancel, and we get a squared plus 2a minus 3 plus 1 equals a squared minus 4a plus 3. Having like terms on one side that we can bring together. Yep, so we have a negative 3 and 1, so we have a squared plus 2a minus 2 equals a squared minus 4a plus 3. What would we do next here? So Derek says minus a squared. Does that make sense? Yes, we want to minus the a squared because we've got to figure out whether we need to solve a certain way because of that a squared, or will the a squareds eliminate? And they do. They go away when we do that. So we get 2a minus 2 equals negative 4a plus 3. And then we would say add 4a. And we get 6a minus 2 is 3. And we get xa equals 5 over 6. Okay, so let's go to this extraneous solution part here. So we need to look and make sure that if we put this in our denominator of the original, will it give us a 0? So this is a fraction. What numbers would give us 0 in the denominators here? 3 and and -3, which this is not 3 or -3, is it? So we're good. It's not going to give us 0, so we're fine. Okay, on to the next one. What's our common denominator on number 2? Let's go back here. What's our common denominator? On number 2, yeah. So if it was a fraction equal to a fraction, we would, but we have 2 different terms on the left side. So let me show you something. If our denominator, say we had a 1/5 plus 3/11, what would our common denominator be? 55. So we have to multiply them together. We don't know what x is, so we have no idea whether x and x plus 6 have any relationship to each other. So we have to multiply them. Our least common denominator is just to multiply x times x plus 6. Does that make sense? No way I can make that x plus 6 equal to an x, and no way I can make the x equal to x plus 6. So I have to multiply both of them. So what do I multiply top and bottom by on this here? Susie. Good. And so I'm going to go ahead and multiply that out. When you multiply that out, what do you get? X times x plus 6, x. Yep, so x squared plus 6x over x times x plus 6. What do we multiply top and bottom of this one by? Anybody in this group? It doesn't have to be just Susie. What's not in this denominator that's in this one? X plus 6, good. We're going to multiply top and bottom by x plus 6. And what about this one? Multiply top and bottom by x. So we get x squared plus 6x over x times x plus 6 minus, let's go ahead and multiply these out. This group here, what do we get when we multiply x minus 6 times x plus 6? Plus 6x. So you could say minus 6x. And then what next? So you have to distribute x squared plus 6x and then minus 36. So these cancel, don't they? So I'm going to go ahead and save space and make it x squared minus 36. And then distributing the x plus 1 times x, what do we get? Blaze, you know what we get when we multiply that out? X times x plus 1. Plus x. Okay, and then this group here, what do we do next? Good. That's right. So we're going to multiply by x times x plus 6 to get rid of our denominators. And we get x squared plus 6x minus x squared minus 36 equals x squared plus x. the same group again. What would we do next?
So combine those together first.
Good.
So it's gonna be -30. No,
So 6x minus 36 equals
x squared.
x squared plus x. So now, anybody? What do we do next to solve this? So this x squared is the key. Because we've got x squared there. What do we do on the warm-up, that first one? We got everything equal to 0. So we need to do the same thing here. So we need to subtract the 6x and add the 36. Because we're going to have to factor. So we get x, these cancel, 0 equals x squared minus 5x. And, oh, shoot. Let me go back to here. This minus is minusing everything that's on the top there. I just made that mistake. That is a frequent mistake. So this becomes plus, and I have to multiply by a negative on both of these, not just the first one, right? So this is a minus, and this is a plus. So minus and then plus 36. So we would minus 36 from both sides. So we have x squared minus 5x minus 36. And so what do we do next? We want to do our x. What multiplies to negative 36 that adds to negative 5? Yep, negative 9 and 4. So that is x minus 9 times x plus 4 is 0. This group here, what next? What's that? Separate them. So we have x minus 9 is 0, and x plus 4 is 0. Yep, x equals 9, x equals negative 4. So our last thing that we want to do is we want to make sure that neither one of these gives us a 0 in the denominator for the original. It would not. So we're good. So x equals 9 and negative 4. Because our zeros would be 0 or negative 6. And neither one of those is a 0 or negative 6. Okay, we're going to skip 3 and we're going to go on to 4. Well, that's the good news. It's not quite as long. So, this group back here, what do we do to find our common denominator? Any of those denominator factors? K squared, that's right. So we're going to look at what multiplies to negative 4 that adds to negative 3. And what would that be? Negative 4 and 1. So this is k minus 4 times k plus 1. So what do we multiply this group back here again? What do we multiply the top and bottom of this one by? K plus 1. And then what about this one here? The negative 2. Negative 2 is the same thing as negative 2 over 1, right? Multiply all of it. Okay, so I'm going to go ahead. I know that when I multiply this out, this is what I get. So I'm going to leave it as k squared minus 3k minus 4. And then it's going to let me do that. And then the bottom is the k minus 4 times k plus 1. Okay, so I get k plus 1 over k plus 1 times k minus 4. And then I have a minus 2. So that negative 2, I need to multiply by everything inside there. So this group here, what do I get when I multiply negative 2 by all? Good. Minus or plus?
Oh,
Plus 6k?
and then plus.
Good job. Good job. She distributed that negative 2. And then this group again, what do we do next? So we're going to multiply both sides by the k plus 1 times k minus 4, which will cancel the denominators. And we get k plus 1 minus 2k squared plus 6k plus 8 equals 5. Okay, pay attention to this next step here. Should we add our like terms first? Okay, so we have a negative 2k squared plus 7k plus 9 equals 5. What's my next step? So if we subtract 5, the problem is this is negative. It has to be positive. So we could do that and then multiply everything by negative on that side, or we could add 2k squared minus 7k and minus 9. Really, it's the same difference. So we get 0 equals 2k squared minus 7k minus 4. Now what's my next step? Let's see if there's somebody else. Let's hear what's my next step. Make an x, yep. And in our x, what do we put on the
Negative 8.
Good, negative 8, because we have to take that 2 times negative 4 to get negative 8. And then what multiplies to negative 8, that adds to negative 7. Negative 8 and 1. And so we have k minus 8, k plus 1. Sorry, one more step before we solve it. So before we do that, there's something we have to do. Divide by 2. Really easy to forget that. So we have k minus 4 times 2k plus 1 equals 0. And so then we want to take k minus 4 equal to 0, 2k plus 1 equals 0. And we get 4 and negative 1/2. Is either one of those a problem in our original? Will either one of those give us a 0 in the denominator? The 4 will. So the 4 is a problem. We cross it out. It's an extraneous solution. Our answer is just k equals negative 1/2.